If you really stop and look around at the way we work today, I want you to ask yourself a question. Do you ever feel like modern technology is essentially just a giant, highly polished house of cards?
Oh, absolutely. Yeah, all the time.
Right. Because you're using all these incredible lightning fast tools on your phone or your computer, but almost all of them are entirely dependent on these massive, invisible, and frankly, incredibly expensive cloud server farms.
Just humming away in a data center somewhere.
Exactly. And the second that remote server goes down or, I don't know, your internet connection drops, that whole digital house of cards just collapses instantly.
We treat the cloud like it's oxygen, just this infinite ambient resource that will constantly be there to do the heavy lifting for us.
Yeah.
But we've largely traded total reliability and ownership really for convenience.
And that dynamic is exactly why the material we are diving into today completely stopped me in my tracks. Today, we are looking at some fascinating excerpts from a project and an experiment really called Sovereign Intelligence, high-efficiency local node orchestration.
It is a brilliantly provocative piece of engineering. I mean, it challenges a lot of basic assumptions in the tech space right now.
It really does. Because the mission of this deep dive is to look at how this project completely breaks that dependency on the cloud. The developers behind this didn't just build, like, another AI wrapper. They built an artificial intelligence system that runs entirely on just two everyday low-end devices.
Right. No server farms, no massive compute budgets.
We're going to explore how they had to fundamentally change the way AI is prompted to make this work, and ultimately how this constraint proves a highly controversial point about the current state of software engineering. So, okay, let's unpack this. Before we get into the complex software architecture, we have to establish the physical reality of this setup.
Yeah, because the physical constraints are the defining characteristic of this entire project. When you move away from the cloud, you are moving away from an environment of infinite resources to an environment of, well, extreme scarcity.
And the source material lays out those constraints very clearly. This sovereign intelligence system is built 100% on two local nodes. Node 1 is an offline Linux Mint laptop, which, for anyone unfamiliar, is just a very utilitarian open source operating system usually run on older hardware.
Right, very bare bones.
Node 2 is literally just an entry-level smartphone. That is the entire physical universe this AI lives in.
Which is a staggering departure from how AI is traditionally deployed. I mean, when we think of artificial intelligence today, we are almost always thinking about data centers.
Yeah, like those football field-sized warehouses.
Exactly. Packed with thousands of highly specialized liquid-cooled graphics processing units crunching numbers simultaneously.
The kind of hardware that literally requires its own dedicated power plant just to keep the lights on and the cooling fans spinning.
It's massive scale.
And here, we're talking about a budget laptop sitting on a desk without a Wi-Fi connection, paired with a standard phone in your pocket. The compute power isn't just reduced, it's microscopic by comparison. They are operating entirely on what we call edge devices.
Right, devices operating at the very edge of the network, rather than in the centralized hub. And what's crucial to understand is how developers split the workload between these two edge devices.
Yeah, how does that work?
Well, it's an intricate dance. The offline Linux Mint laptop acts as the brainstem, essentially. It handles the system orchestration, maintains the core database, and manages the state of the application.
Okay, so the laptop is the manager.
Right. The smartphone, on the other hand, acts as the sensory input and the actual inference engine. It runs a highly compressed local AI model with only about 0.5 billion parameters.
Wow, that is tiny.
It really is. For context, the large language models running in the cloud often have hundreds of billions or even trillions of parameters.
I hear what you're saying about the technical achievement, but let's be real for a second. This reminds me of digital off-gridding.
How so?
Well, if I'm sitting right next to a sprawling city power grid that offers cheap, limitless electricity, choosing to go build a cabin in the dark woods and chop my own firewood isn't sovereignty, it's just making my life unnecessarily hard.
I see what you mean.
Why inflict that kind of pain on yourself as a developer? Why build an incredibly restricted 0.5 billion parameter model on an offline laptop when you could just ping a massive cloud server for pennies?
It comes down to a fundamental philosophy about data, which is right there in the title, sovereignty. Relying on the cloud fundamentally means relying on external hardware.
Right.
And if your intelligence system requires external hardware to function, you do not truly own or control it. You are entirely at the mercy of their terms of service, their privacy policies, their server uptime, and their pricing models.
Which means you're basically just like renting space in someone else's brain. The moment they change the locks, you lose everything.
Exactly. And for sensitive data, or for systems that need to be completely fail-safe, that is an unacceptable risk.
Hmm.
By forcing the system onto this two-node setup, the offline laptop and the local smartphone, the developer reclaims absolute, total sovereignty. The intelligence belongs entirely to the local environment. It is completely insulated from the outside world. No data ever leaves the room.
Okay, so you have this isolated, totally secure off-grid setup. But practically speaking, the physics of shoving an AI workload onto a budget phone must be an absolute nightmare.
Oh, it's incredibly difficult.
I mean, a zero point 0.5 billion parameter model is tiny, it's stripped down, it lacks the vast statistical context of a cloud model.
But the environment dictates the evolution of the software. Because you are heavily restricted to the phone's processor and the laptop's limited RAM, you simply cannot afford the processing waste of a traditional AI setup.
Right, every cycle counts.
Exactly. This physical bottleneck directly causes the need for a total architectural shift in how the AI is directed.
And the source refers to this architectural shift as the engine. And specifically, it notes that the developers had to completely abandon standard loose prompting and move to a strict schema-constrained architecture.
Which is the pivot point for why this local system actually functions.
Let's talk about why that's necessary, because typically the whole appeal of interacting with an AI is that you can talk to it like a normal human.
Right, the conversational aspect.
Yeah. You use loose prompting, you give it a vague direction like, hey, brainstorm some marketing ideas for this new product, and you get to see what creative, unexpected things it generates. Doesn't forcing a strict schema completely kill that magic?
He does.
It sounds like we're taking a brilliant, creative conversationalist and turning them into a rigid data entry clerk.
What's fascinating here is that you're entirely correct about the loss of that conversational magic.
Oh.
But you have to look at the computational cost of that magic.
Okay.
In a cloud environment, when you use a loose prompt, the AI has a massive statistical playground to wander through to formulate your answer. It is calculating probabilities across billions of parameters to sound human.
Right.
And because it's wandering, sometimes it wanders down the wrong path. It guesses incorrectly. It confidently invents facts. That is what we call a hallucination.
It's like last week when an AI confidently told me a specific historical figure invented the toaster.
Exactly.
Which is funny when you're just messing around on a cloud server. You laugh, you tweak your prompt, and you hit generate again. It takes 2 seconds.
Because the massive data center absorbs that mistake instantly. The cloud has the limitless processing power to try again. But consider the reality of our budget rig.
Oh, right.
We're running a 0.5 billion parameter model on a smartphone battery. When hardware constraints are that tight, an AI hallucination isn't just a quirky, funny mistake. It is a catastrophic waste of the machine's incredibly limited processing power.
If my phone spends 3 minutes of its battery life and CPU capacity generating a beautifully written, highly creative, but factually incorrect essay about a toaster, the system has failed.
Completely.
I've wasted time, battery, and compute for absolutely nothing.
And the local node simply cannot afford to let the AI wander creatively. It cannot afford the search space where hallucinations occur. This is where the schema-constrained architecture becomes absolutely necessary.
So how does that work in practice?
Well, a schema constraint means the system orchestration layer mathematically forces the AI to output its data in a very specific machine-readable format, and in this case, most commonly, a strict JSON format.
Let's break down what JSON is for the listener, just so we are all on the same page. It stands for JavaScript Object Notation, but essentially it's just a highly structured text file that machines use to talk to each other.
Right, it's purely structural.
There's no punctuation for tone, there's no grammar, there's no hello, here is the answer you requested. It is purely key-value pairs, like name : John, age : 30.
It strips away all the computational weight of human pleasantries. But more importantly, the strict schema physically prevents the model from searching outside its predefined boundaries.
Wow, okay.
When the orchestration layer sends a prompt to the 0.5b model on the phone, it doesn't ask an open-ended question. It passes the raw data and provides the exact JSON template it expects back.
So the model can't even try to be creative.
Exactly. The model isn't allowed to predict conversational tokens. Its probability generation is locked down to only predict data values that match that specific template.
So it's basically putting the AI on a highly specialized single track rail. You are eliminating the hallucinations by eliminating the AI's ability to choose its own words. It parses the data, extracts a specific value, and slots it directly into the template.
You trade conversational magic for absolute, ruthless operational efficiency.
That is so smart.
It is. And this ties directly into another vital mechanism the developers build to handle this restricted environment, the human-in-the-loop fallback workflow.
The source material highlighted this, and I found it brilliant. Because no matter how strict your schema is, a tiny 0.5B model is occasionally going to encounter data it simply doesn't understand.
Absolutely. In a cloud setup, when an AI gets confused, it often just starts looping, or it forces a hallucinated guess to complete the prompt. Again, massive compute waste.
Which we can't afford on the smartphone.
Right. So in this sovereign intelligence setup, the orchestration layer on the Linux laptop is constantly monitoring the phone's output. If the local model begins to violate the strict JSON schema or its confidence score drops below a certain threshold, the orchestration layer instantly halts the process.
It doesn't let it guess. It kills the process before the processor wastes battery.
It pauses the automated workflow and kicks the specific data point to a human-in-the-loop interface on the smartphone.
So a real person steps in.
Exactly. The user gets a ping, looks at the confusing data, manually inputs the correct value into the schema, and the automated orchestration resumes.
It acknowledges its own limitation rather than burning down the hardware trying to fake an answer. That is incredibly elegant.
It's a perfect failsafe.
Which really naturally brings us to what the source material explicitly calls the win. Because going into this, you'd assume that this strict, unforgiving approach, the budget hardware, the total lack of conversational UI, the constant human in the loop monitoring, is just a survival mechanism.
Right, you think it's a compromise.
Yeah, you'd think it's just a clever, somewhat painful trick to get an AI running on an old phone. But the developers argue it actually produces a superior, more robust overall system than what we see in the cloud.
The friction of the constraint produces a fundamentally better final product. The text highlights that this project proves that deliberate hardware limitations breed cleaner, highly efficient code and system orchestration.
I was trying to visualize why restriction creates better results, and the best way I can describe it is with a packing analogy.
Okay, let's hear it.
Imagine you are going on a 2-week trip, and you have this massive, oversized suitcase. That giant suitcase represents infinite cloud computing.
Oh, I see where this is going.
Because you have all that cavernous space, you pack sloppily. You throw in 4 pairs of shoes you definitely won't wear. You toss in a stack of books you won't read. You don't even bother folding your shirts properly. You just shove them in. The space forgives your messiness.
The abundance allows for and almost encourages laziness.
But if you are forcing yourself to travel with only a tiny 20-liter backpack, which represents our offline laptop and phone setup, your entire mindset shifts immediately.
You have to be ruthless.
Every single item must be strictly necessary. Every shirt must be perfectly rolled to maximize space. You meticulously organize the compartments. The physical restriction forces you to become a master packer.
That is a perfect analogy. And if we pull that back to the bigger picture of the tech industry, that massive, sloppy suitcase is exactly how most software is built today.
Is it really that bad?
Oh, absolutely. The era of limitless cloud compute has allowed developers to write incredibly lazy, bloated code. I mean, why spend hours optimizing an algorithm to run efficiently when you could just rent another server from Amazon or Google to handle the extra processing load?
It is genuinely cheaper and faster for companies to just throw raw computing power at bad code than it is to pay an engineer to write highly optimized code.
The servers can handle the mess, so the mess becomes the industry standard. This is why modern applications take up gigabytes of space to do things that used to take megabytes.
Yeah, that makes so much sense.
The true triumph of this sovereign intelligence setup is proving that artificial, deliberate constraints force developers to be better at their jobs. When you only have the RAM of an entry-level smartphone and the storage of an old laptop, you can't afford a single wasted line of code. You can't afford an inefficient data transfer between the two nodes.
It strips away all the fat until you are left with just the pure functioning muscle of the program. And the source specifically points to how this radically improves database mapping.
Oh, the database mapping is arguably the best part. Because the AI is forced to output in that strict JSON schema we talked about, the orchestration layer receives perfectly clean, highly structured data every single time.
There's no messy, unstructured conversational text to parse through. The laptop doesn't have to guess what the phone meant.
Exactly. The database mapping becomes flawless. In cloud architectures, companies spend millions of dollars and massive amounts of compute just cleaning and organizing the messy data their loose prompted AI models generate.
Wow.
But in this local setup, because the constraint was enforced at the point of generation, the data slots perfectly into the database. The system orchestration runs like a Swiss watch.
The restriction is the very thing that creates the brilliant efficiency. It's a total paradigm shift. It completely flips the script on how we've been taught to think about progress in technology. We are constantly sold the idea that bigger is better, bigger data centers, bigger language models, more parameters, more compute. But this project is waving a massive flag saying, no, smaller is smarter.
It really raises a vital, almost philosophical question about the current trajectory of software engineering. Like, how much of our technological advancement over the last decade is genuine, elegant innovation, and how much of it is just us brute forcing our way through wildly inefficient software using massive amounts of external hardware?
It makes you wonder what else we could achieve if we stopped relying on the brute force of the cloud. Okay, we've covered a tremendous amount of deeply technical ground today, so let's distill this down for you listening right now. We started by looking at an experiment that completely ditches the cloud for an entirely sovereign, offline, two-node setup.
Right, a Linux Mint laptop orchestrating the system and a smartphone running the actual inference.
A setup that instantly creates massive hardware constraints, and those constraints necessitate a total shift in software architecture, moving away from creative Luth prompts to strict schema-constrained prompting. By locking a zero point 0.5 billion parameter model into a JSON template, the system physically prevents the search space that causes catastrophic AI hallucinations.
And when the model does get confused, the orchestration layer instantly utilizes a human-in-the-loop fallback workflow to prevent any wasted compute.
Ultimately, this massive amount of friction and limitation results in beautifully efficient code, flawless database mapping, and a system that proves deliberate hardware limits breed better engineering.
It is a powerful reminder that constraints aren't always a barrier to innovation. They are very often the primary catalyst for elegance.
Which leaves me with a final thought for you to mull over today. This project definitively proves that deliberate hardware limitations breed cleaner, better output for our machines. So, looking at your own life or your own workflow, where have you been relying on limitless resources?
Yeah, with your massive suitcase.
Exactly. Maybe you have an endless open ended timeline on a creative project. Maybe you have an unlimited budget for a marketing campaign. Or maybe you just have access to an overwhelming, distracting amount of software tools. Is it possible that those limitless resources are actually making your output sloppier?
It is a fascinating reflection. The abundance of resources might be the very thing holding back your sharpest work. The massive suitcase is making you a sloppy packer.
What deliberate limitation could you impose on yourself today? Maybe a radically shorter deadline, a stricter budget, or forcing yourself to use only one basic tool to spark a breakthrough in your own efficiency. Maybe it's time to realize that you don't always need an infinite cloud of resources to build something great. Sometimes you just need a smaller suitcase. We hope this deep dive gave you a few of those aha moments today. Keep questioning the defaults, keep looking for smarter, more sovereign ways to build your world, and remember the next time you feel like everything you do is resting on a fragile digital house of cards, know that it doesn't have to be that way. Thanks for joining us.